So my name is Alicia Cash, and I'm a regional coordinator with the Florida Friendly Landscaping Program. This session we are about to listen to is Understanding Climate Change in Florida. Very exciting topic for me, at least. So we have Miss Holly Abeels. Holly has been the Florida Sea Grant Agent for the University of Florida IFAS Extension in Brevard County since January of 2010. She has a Master of Science in Environmental Science from Florida Gulf Coast University and a Bachelor of Science in Marine Science from Long Island University Southampton College. As an extension agent, she brings science-based information to the community in areas of natural resources, sustainability, climate change, and water quality and conservation. So awesome topics. My program is also water quality. Her extension programs include teaching the Florida Master Naturalist Program, working with communities to address climate change and sea level rise, and working with volunteers on projects like the Florida Horseshoe Crab Watch. So I will go ahead and turn it over to Holly, and we will be saving questions. Go ahead and chat all your questions, and we will be saving about 10 or 15 minutes at the end for questions, and we'll address those then. So Miss Holly, it's all you.
Thanks so much. Let me get my screen up. Can we see that okay?
All good.
Awesome. Okay, yeah, thank you for that great introduction. I'm Holly Abeels, Sea Grant Agent in Brevard County, so East Central Florida, and I'll be talking to you about climate change in Florida today. So let's get started. So I'm not gonna be able to see the chat, but I do want you to put in the chat, if you could, just a phrase or a word that comes to mind when you hear the words climate change or global warming. And I'll give that just one second, and maybe Alicia, if you can just tell me a couple things you see.
So floods, sea level rise, worry, doomed, dread, danger to all life, human impact, yikes, wildfires, death of plants and environment. So yes, this is an important topic. More storms, our children's future. Yeah, these are all very good.
All right, luckily I have at the end a uplifting couple slides, so hopefully we can turn some of those into thinking more, I guess, maybe not positively, but hopeful. Okay, thank you guys. I always like to start that because I just like to see kind of where people are thinking and where they're at, and it just helps me to best relay, some good information in this presentation. So just to start, we're going to start with just some basics. And so, as you know, I'm sure, weather and climate are not the same thing. So weather is what's happening outside your window right now. So I actually took this picture here on the left outside my house at about 10:30 this morning. And so this is what the weather looks like today. It's bright and sunny. There's a couple, clouds in the sky, but, the weather is turning cooler in my part of the Florida. So, and, in general, when we think of weather, we watch maybe the weatherman every morning or check out the weather on our mobile apps. And we know whether we should bring a raincoat or umbrella. We know what the temperature is going to be like. We know what we should be wearing. So we can kind of expect what's going to happen today and maybe over the next couple of days, right? But it's fairly difficult to predict. We can't necessarily say, it's going to rain at, 4:35 p.m. today. So like, and it could change rapidly, as we know here in Florida, right? So we especially get those pop-up thunderstorms during the summertime. So limited, short-term, changes rapidly, difficult to predict. But climate, when we talk about climate, we're actually talking about the average of many years of weather observations over the long term and over a wide area. And when I say long term, in this case, I mean 30 years or more. So we're looking at many, many years. of all different types of weather parameters, looking into what the climate's like. So we cover a wide area. It's not just what's happening in your city or your county, and it takes into account seasonal changes. And I'll talk a little bit more about what we call climate normals and what that means, because we had a change in the climate normals earlier this year. So as I'm talking about climate change, I want you to think about this climate meaning long-term, many decades, wide areas, covers all different types of weather parameters and changes. And climate's affected by a lot of different factors. So there's things like where you live in the world. So we know here in Florida, it's warm most of the year. We have maybe a couple months where it gets a little bit cooler. But if you're up north, like from New England, where I'm from originally, we know this is the time of year where fall comes, and then we have winter and spring, so we have seasons. It also is based on ocean currents, maybe things like volcanic activity, depending on where you live, evaporation, solar radiation, and also things like, photosynthesis from the plants that live in our environment, decomposition, things breaking down in the environment. So things I'm sure you guys well know that happens, in our gardens and our landscapes every day. And when we hear or think about climate change, we often think first about greenhouse gases. And these right here are the most common greenhouse gases we refer to when we're talking about greenhouse gases, and carbon dioxide being the one we probably hear most about, but these other three, water vapor, methane, and nitrous oxide, are also important. And without these greenhouse gases, Earth would actually be a frozen world. So these gases trap sunlight that hits the Earth and reflects it back, causing the Earth to warm. And sometimes the greenhouse effect is referred to in the education circles as a heat trapping blanket, because sometimes it's just an easy way to understand how important the greenhouse effect is to life on Earth. So, but too much carbon dioxide or greenhouse gases in the air makes Earth get warmer and warmer. It just makes that blanket thicker and thicker. It's like you're putting more and more blankets on the bed. And scientists have known about this effect since the 1800s. So this isn't something that's, new to us. And speaking of carbon, carbon is a really important element, for our ecosystems and our natural environments. All living things are made of carbon. It's also, part of the ocean, the air, even rocks. And because Earth is a pretty dynamic place, carbon doesn't stay still for very long. It is on the move constantly. So in the atmosphere, carbon's attached to some oxygen and a gas, carbon dioxide. Plants, as you guys well know, use carbon dioxide and sunlight to make their own food and grow. And carbon becomes part of the plant. Plants that die and are buried may turn into fossil fuels made of carbon, like coal and oil, over millions of years. So those fossil fuels we use. And when humans burn those fossil fuels, they're basically releasing that carbon quickly into the atmosphere. And so we've seen over time, carbon dioxide as that greenhouse gas, and as we burn fossil fuels, we know it helps to trap heat in our atmosphere and keep the planet warm. So as we see an increase in carbon dioxide, we see an increase in temperature at the same time. So we can see this effect that's had on our planet. We see increasing temperatures, and we can track this, over time in many places across the world. So this is how we know that as carbon dioxide increases, temperature increases. I also want to briefly talk about sea level rise, because that's really important here in Florida, and that at least one of you mentioned sea level rise when you think of climate change. And I just wanted to point out the two major causes of global sea level rise. So they are thermal expansion, and so that is because our waters are getting warmer. The water expands. And so if you think back of, maybe high school Charles' law, so as you warm up the temperature of water, that expands as the water gets warmer. Also, we have the loss of land ice due to increased melting. So I'm talking about not talking about icebergs. I'm talking about ice that's already that's on land. So if you think of like a glass of water, right? You put ice in your glass of water, you put water in. You know, if you don't drink that water over a long period of time, the ice melts, but the water level doesn't change, right? So I'm talking about ice that's actually on top of land, that when it melts, it's kind of like a river flowing into our ocean. And there is more and more work looking at especially the melting of land ice and what that's going to look like over the years, because it's still a kind of a big unknown as to how much that's going to affect sea level rise and when. And I also wanted to point out that one important thing to note about sea level rise is that it doesn't rise evenly around the world. This is showing like the global average. So this is what's happening overall, the different tide gauges and satellite data across the world, you know, where we can measure sea level rising, but it's not the same everywhere. So if you think of a place like Louisiana, in our Gulf of Mexico, sea level is actually rising faster there than the average because the land is shrinking. So as the oil and the fossil fuels are being taken out of the ground, it's actually causing kind of like, normally there would be a pocket of those fossil fuels, right? And as you decrease that pocket, the land actually sinks down and down, it sinks further and further. So sea level rise is rising much faster in Louisiana than in other parts. And then there's places like Alaska where the sea level is either not rising or it's actually getting lower because all of those melting land ice, those glaciers that used to be on the land, which is very, very heavy, as they melt, it kind of makes the ground actually bounce back up because there's not that weight of those glaciers on the land. So in general, global average of sea level rise has risen about 8 inches since the 1900s, and about 3 of those inches have occurred since 1993. So we kind of have an acceleration of sea level rise over the past several decades. And the current rate is a little more than 1 inch per decade. And so we have a lot of different things that affect climate change, and the risks of climate change across the world is different depending on where you are. So like in some places like near us, hurricanes and typhoons and sea level rise are going to be really important and maybe a larger risk than other things. But in other places, flooding is going to be a bigger risk. Heat stress is going to be a big risk. You know, wildfires, you know, we hear about wildfires a lot along the West Coast. So there's lots of different things across the world that's going to affect different areas related to climate. And this will change over time. And there also will be compounding risks. So even though we have the effect of, say, hurricanes and sea level rise here in Florida, we also will have like heat stress and water stress as we move forward as well. So there's just a lot of different kinds of things to think about when we think about climate change and the different risks across the world. So I just want to briefly next talk about, you know, our communities and our natural resources and infrastructure, and just point out how those are being impacted and how they're going to continue to be impacted. So first, I want to talk about our climate normals. So if you listen to, you know, the weathermen during the day, in the morning, say, and they say something like, you know, today's temperature will be 5 degrees above normal, you know, for this time of year. What they're using for normal is basically the average of temperatures over the past 30 years. And so we just passed a new decade, 2020 last year. So now we have the decade of the 2010s, the 2000s, and the 1990s. All of that averages together is creating our new normal. And you can see over time for temperature, that new normal has increased over time. So our temperatures in general have increased. So that means the averages of those temperatures have also increased. And so our normal is that baseline temperature that we're saying is normal, is greater now, than it was, many, many decades ago. So if you hear today that the temperature is going to be 5 degrees above normal, that's going to be much different than if you heard it was going to be 5 degrees above normal, say in, even back in 2000, it would have been very different. And because there is an increase in temperature, and we kind of see the averages of temperature increasing, one of the biggest stresses and risks that we have to think about here in Florida, but also across the United States and the world, is that there's going to be more intense warm or hot days, and more days where we're going to see higher temperatures than normal. And especially with us here in Florida, humidity will also become a greater factor as well. So humidity, as we know, makes temperature feel, much warmer, more sticky. There's more water vapor in the atmosphere, so it just ends up feeling much warmer. And the combination of those can really cause a lot of stress for many, many people. Think of all the people who work outside every day, whether they're working in agriculture or they're working on our roads, working on the different types of infrastructure that we have. So, all those people who work outside every day, who don't necessarily get to work in air conditioning all day, they're going to be more and more stressed as temperature increases. And we see a greater amount of that stress in like the Midwest or the middle part of our country, like Illinois, Indiana, Wisconsin, those different places. And here in Florida as well. So it's already pretty warm, in the deep south. We're going to just see, more and I guess greater warmth. And there's more and more discussions and talk going on about like that human health impact of those increase in heat, the increase in temperatures, how that's going to affect different communities, especially lower income communities, places that don't have air conditioning, or there's not a place for people to go to get out of the heat, or for those that are like, out working outside all day on our infrastructure, our roads, in agriculture. So that warming is the new normal. Like I said, the climate normals, they give us a good information about things like when growers, want to plant their crops or what crops to plant, how electrical utilities can expect energy demand to vary by season, planning for construction projects. And as you can see here, that normal, has warmed or increased since the last normals. And these normals, like I said, were updated just earlier this year. And even extreme heat, that looks much different today than it did, 50 years ago. So here's a graphic just showing that, just for West Palm Beach, just one city in Florida, they have 15 more days of extreme heat. So days, with the heat index above 90, back in, in 2018 compared to 1979. And actually more than half of cities that Climate Central looked at to see what this, extreme heat looks like, more than half of them, so about 150 cities, are experiencing 3 or more additional days each year of extreme heat. And of course, we also hear every year that, the year previous, is always like the hottest year on record. 2020 was the second hottest on record, just behind 2016. And this extreme heat, like I said, is really dangerous. It is, besides if you think of flooding or hurricanes and stuff like that, it is really the top weather killer. And it's really difficult, to shelter from, especially if you think of, 2020, where people mainly were staying at home. And if you didn't have air conditioning at home, where were you going to go to kind of, get out of that heat? And I just wanted to highlight this documentary, which if I remember at the end, I'll put the link to it in the chat. But it's from the Southeast Coastal Center for Agricultural Health and Safety. And they actually did this documentary with researchers at Emory University that partnered with the Farm Worker Association of Florida to conduct collaborative research on heat-related illness with farm workers. So they actually took things like blood or blood pressure or temperature, different types of health related parameters from farm workers, and to see how that changed over time, and especially with heat, with days that were really, really hot. And they did this in order to help those employers that were hiring those workers, how they could better address, workplace safety, and, maybe address some of the things that they could do to help people get out of, the heat during the day. So in addition to heat, precipitation is another factor that has been increasing or decreasing depending on where you live. There's not really a great trend as to, places being wetter or drier, even though we have seen, many areas that have been drier, especially on the West Coast of the United States. But as our planet warms, there is a greater evaporation, so there's more water vapor in the atmosphere in general, and that does cause more rain to occur. And of course, we've heard this year of many instances of large rain events affecting communities in Europe, in Germany. We heard about that in New Jersey and New York earlier this year. So we know precipitation, flooding are going to be very big factors moving forward. They already are a factor and already are impacting us. And extreme rainfall will affect different areas. So here, on the eastern United States, we will see kind of more of these extreme rainfall events in general compared to other areas. And then if you're looking on the West Coast or the western part of the United States, you're going to see things like less water or more drought. And this has effects, not only for thinking of flooding or places that might have too much rain or too much water. You also have to think about places that are going to have too little, and the different types of infrastructure that need that water. So whether that's water for drinking or wastewater systems, energy, food, agriculture, all of those are, critical infrastructure sectors that are most vulnerable, to drought conditions. And in general, here in Florida, we get maybe more rain, or it rains more each year. It's not like a big trend. There's a lot of variability depending on the year. I think of, I guess as far as weather, what's currently happening, we've had a pretty dry September and October. That might be that's usually when we see the most hurricanes come in our area, and we really haven't seen any. So we really haven't had a lot of rain, the past couple months. So that's, weather that's affecting us, currently. But like I said, for every, as the temperature increases and for every 1 degree Fahrenheit of warming, the saturation level of the atmosphere, so the amount of water in that atmosphere, increases by about 4%. So that's more water to come down as precipitation, as heavier downpours, and that heavier rain means flooding, flash flooding, larger river flooding, which leads to things like property damage, especially affecting people's homes or roads. We often see information or see pictures about roads being washed out. And excluding tropical, systems, tropical cyclones, the individual billion-dollar flooding events in the US have added up to, $39 billion in losses since 2010, just related, to flooding. If you include tropical cyclone damage estimates, that makes it over 400 billion. So, more rain and more water does have a large effect, not only in the areas where it's flooding, but huge losses as well, huge economic losses. One of the benefits, I guess you could say, for a warming temperature and potentially increase in rain is that we might see longer growing seasons in some areas. So, but this also means potentially longer allergy seasons. If anyone has allergies like myself, this could make those allergy seasons longer. But we also might be able to grow crops in places that we previously weren't able to grow, or plants might be growing longer, or start growing earlier in the season and through the summer and then later into the fall, or growing in areas where previously they hadn't previously grown. And I'm sure you guys are really well familiar with obviously plants and where they grow and how best and what the things they need to grow best. And maybe there's some areas where you've seen, some plants that are growing in areas you hadn't previously seen before. So, like I said, we will see, in general, that water evaporating and getting into the atmosphere, and that will help to make, stronger hurricanes. So not only the water that's in the atmosphere, but also just the warmer water in the ocean. As the water warms, that just becomes more fuel for hurricanes. And really, it doesn't mean that we're going to have like a greater number of hurricanes. It just means that our hurricanes are going to grow stronger over time. And so that maximum wind speed is going to be greater. And I think we've seen this over the past couple of years, right? There's definitely been some hurricanes that have kind of grown pretty quickly and, became, say, category 3, 4, 5 hurricanes, over a short period of time. You just think of Hurricane Michael several years ago that became a major hurricane fairly quickly, and it really leaves little time for people to prepare and to either evacuate or to board up, their homes and businesses before the hurricane comes. And the biggest threat to life from hurricanes is actually storm surge. So that coastal flooding, that storm surge that comes inland, that actually causes more damage to infrastructure and puts a lot more lives at risk. So we'll see an increase of that storm surge or higher storm surge as our sea levels rise. And weather and climate events do have a huge economic impact, as I mentioned before. So back in 2020, we had $22 billion disasters last year. So that cost us a total of $96.5 billion and 262 deaths. So that severe impact of climate change is going to continue. We're going to see more of these billion-dollar disasters. And so it kind of is another impetus for thinking about, cutting our CO2 emissions so we can potentially decrease these types of disasters in the future. Excuse me. And I also wanted to just point out too, something I mentioned earlier is that there's a lot of different types of climate hazards. So it could be storms, it could be sea level rise, it could be heat waves, it could be flooding, it could be wildfires. And we're going to see an increase of all of these at certain levels and degrees, and everywhere where we are. And it's the compounding of all of those different hazards which are going to have a greater effect, right? So say we only had to deal with more storms or hurricanes. That's the only thing we had to think about. there's probably a lot of things we could do to mitigate that or to adapt to having more of those storms. But if we have more storms and greater sea level rise, okay, now we have to think about more water coming into our cities, during storms, or more flooding that's going to occur. And if we have to think of heat waves as well, okay, so now we have, so many hot days. We have to, find ways to help people who are working out in the environment and maybe who don't have air conditioning, and they can have these, cool centers where they can go during the day to get out of the heat. And if we're even losing water, if we are in a drought, okay, now we have to think about how we can conserve water, to get water to where it's needed for drinking and agriculture and stuff like that. So there's lots of things to think about, and all of these are happening all at once. So it's just kind of compounding, and it's just making it so we have to plan for more things, and to think, I guess, harder or more deliberately about all the different things that we need to do. And this is just another showing, the past graphic was for West Palm Beach, the different types of hazards. This is one for Orlando. So I wanted to show a coastal city and then an inland city. And then this is just from a ProPublica study. So I looked at over 3,000 counties across the United States and looked at their climate risks. So that would be heat and humidity, wildfires, sea level rise, farm crop yields, economic damages, and looking at all those impacts, showing that some counties are going to have more of these compounding issues than others, and they're stacked on top of each other. So here's about 21 counties in Florida that were sort of top of that listing. So they were in the top 100 of those 3,000 counties listed, showing that there's just all these different types of hazards and risks, in these counties that we have to be thinking about. And of course, living in Florida, we have a lot of risks that we have to think about, like sea level rise, heat and humidity, flooding, and stuff like that. So I just want to go a little bit into specific different areas where we're going to see impacts. So this is talking about natural resources, horticulture, and agriculture. And I'm sure you guys can already think of a variety of different types of impacts to these different sectors. So, shoreline and beach erosion is a big one. If you even just think of not even the plants and animals that live on our beaches, but the tourists who come to Florida to go to our beaches. Florida is, a tourist hotspot for a lot of our economy, and the money that comes into our state is because of tourists. And our beaches are one of those things that a lot of people come to go to. So if we have less beaches, or maybe those beaches are washing away more from storms, that's that's a greater economic impact for those areas that rely on those beaches for tourism. Oops, sorry. But we'll also see shifts in habitat and species. So there'll be plants and animals that are found in areas that previously they maybe weren't found before. The one that can come to mind right now is mangroves. We actually see mangroves kind of moving further north. So you actually see them more in the panhandle where they previously weren't seen. So they're growing in like our salt marshes and everything. You also have to think of animals like, say, the python, the invasive python. That's found in great numbers in the Everglades. As our temperatures warm, they could be migrating north. Different pests and diseases that I'm sure many of you can think about, for the different plants that we have here in Florida, those could increase. We also could have reduced soil quality for our plants and fewer pollinating insects for our plants. As far as infrastructure, there is a lot of costs of not only protecting our homes and properties and roads from rising seas or flooding, but just thinking about, where people move, how people move from one area to another, how best we can, adapt to these flooded areas or rising seas, and basically putting money into infrastructure changes that need to be made in order to make sure that we protect these areas. And a lot of this work is being done in places like Miami, where they are drastically having to change, different infrastructure like roads. We also have to think about our ports and places where our transportation of goods is moving from one place to another. So think of the several ports that we have in Florida that bring goods in. Our highways, our causeways, our bridges, our power plants, our airports, basically the places where people and goods are coming in and out, those are all going to be affected. And, transportation is going to be a huge area where funding will have to go to protect these areas. And for, say, people like us, with our homes, we could have increased homeowner and flood insurance costs. There actually is going to be an increase of flood insurance that's being implemented over the next several years. There's been a lot of talk here in Florida about people being able to get mortgages, because when you get a mortgage, you have to get insurance. And there might be a time sometime in the future where it'll be really difficult to get insurance for homes here in Florida because of flooding and hurricanes and other things like that affect, our homes. So this is not going to happen. This is going to happen not only just in Florida, but in other areas too that flood. And that tourism revenue that I talked about earlier. So if we have places that are flooding or eroding, or are being impacted by all these different climate risks, that's going to decrease our revenue as well. But there also are different innovations and inventions that could be created in order to combat climate risks. So if you just think of renewable energy or even other technologies we hadn't even thought of before that are being built in order to reduce our use of, say, fossil fuels and other things like that. So that innovation could also bring jobs to our state and to other areas as well. And I don't want to gloss over just the social and human impacts. So there's, in general, a lot of stress that comes to, being impacted by these different climate risks. Think of flooding, of hurricanes, of either lack of water or too much water, of heat. So all of these cause, just in general stress for people. It causes health impacts, and there's definitely more and more work looking at health impacts of climate on a variety of different populations, especially the homeless or the elderly or low-income areas, but to everyone. There's definitely areas like maybe our rural communities that have less resources or less funding to be able to combat some of these risks. And for communities that are inland and not along our coasts, they actually might become places where there'll be climate refugees. So people who are leaving our coastline and moving inland to get away from flooding and sea level rise. As they move inland, there's going to have to be more and more places for these people to live, right? So you'll have inland communities that will have a greater population over time, and having to plan for that. So I've talked about definitely a lot of different challenges that climate change is bringing to our area, and we're going to continue to see a lot of these over time. But there's things that we can do about this. So it's not doom and gloom completely. There's already lots of great work that's being done to combat the risks from climate change. And I wanted to just highlight two different types of responses And mainly I want to highlight them because there was a really good report that came out earlier this year where people from the general public were asked about different climate terms and what they mean. And two of those terms, mitigation and adaptation, which are talked about pretty frequently in the climate realm, people didn't quite understand what those meant. So when we talk about mitigation, we're actually talking about reducing climate change. So we're reducing the flow of greenhouse gases into the atmosphere. So that's either by reducing the source of these gases or so like burning less fossil fuels, using more renewable energy, or enhancing the sinks, so the places where greenhouse gases are stored. And so that could be things like our oceans, our forests, our soil. So the goal of mitigation is to avoid significant human interference with the climate system and to stabilize those greenhouse gas levels within the atmosphere. So when I'm talking about, when people and scientists and people in the climate realm talk about mitigation, it's basically reducing those amount of greenhouse gases that are going into the atmosphere. Versus adaptation, which is basically just adapting to our changing life, to the life that is going to happen in the future because of climate change. So this involves us adjusting to actual or expected future climate. So we're trying to reduce our vulnerability to the harmful effects of climate change, so like sea level rise or more extreme events or floods, or even things like food insecurity. It also encompasses making the most of any potential beneficial opportunities associated with climate change, like those longer growing seasons I talked about earlier. So that could be a benefit, and maybe we could take advantage of that. Or maybe even increased yields in some regions. So maybe there'll be more of something that's growing that we can harvest, for our benefit. So adaptation is basically adapting to what's happening right now and into the future and what that's going to look like.
Holly, you've got about 5 minutes.
Great. I only have a couple slides left. Thank you. So I do want to leave you, that was so much information, and it does seem so overwhelming. And one of the great things about my job is that I'm working with communities to mitigate and adapt for climate change. So what are the things that they can do now, where they can plan for the effects that they're seeing now and effects that are going to happen in the future. And there's so many great communities and people in Florida, that are working towards these plans and working towards adaptation and mitigation. So there's a lot of great work, and I don't want you to feel discouraged and feel like that nothing is happening, because there's a lot happening. And even just this year, we've seen a lot of things happening at the federal level and across the globe even. So, but you also have a voice, and your actions do matter as well. So if you just think about your home and being on the road, probably all the things you guys already do related to being more environmentally friendly or sustainable. So looking at ways to reduce, reuse, recycle, refuse, use water efficiently, both in your landscape and in your home. If you can, do solar or buy a fuel efficient car. There's more and more electric cars that are being put on the market. And as the years go on, there'll be more and more of them, and they'll be cheaper. And take other types of transportation besides your car if you can. I know Florida is not a great place for alternative transportation, but we will get better at it. Look to see what's happening within your own community. So, ask questions to your community members or your mayor or your county commissioner. Ask what they're doing. Stay informed. Promote sustainability where you work or at home or with the people you talk to, and talk about climate change. Talk about what's happening now and how people can help. And reach out. So talk to your neighbor, your friend, sign up to receive maybe a newsletter that talks about work related to climate change, attend, public meetings or community forums. There's lots of organizations or groups that are working towards sustainability or looking at different things you can do to combat sea level rise. And just get involved as much as you can, keep yourself informed. That's, I think, one of the best ways to kind of feel like it's not doom and gloom. It's just by hearing all of the great work that's happening and what's being done, it just helps you to feel more hopeful and uplifted and know that things are going on. But you can also be involved as much as you want to in this. And no, it's not too late to plan. So I know it feels like there's a lot of effects that are happening, a lot of risks that are happening, but we can work towards a better world with climate change happening. The problem's not insurmountable. Any types of decisions we make today can improve, our ecosystem, our Earth, and improve our own quality of life for ourselves and for everyone else that lives around us. And that's all I have.
All right. Well, we do have some questions. So I'll start with a couple of those. There were two that were sort of similar at the beginning. So there was a slide that showed that Florida will endure both more heat stress and drought and more rain. So how are both of these happening? And then the other question that was very similar, is how do we have a water deficit and increased flooding?
Yeah, that's a great question. I'm just going to end my slideshow so I can get into a bigger screen here so I can see. There we go. Yes, that's a great question. So in general, when we think of too much or too little water, one of the generalizations that usually is made is that places that are wet now will be more wet, and places that are dry now in general will be more dry. So we actually do have a great change of like how much water falls even here in Florida. So like in general, the Panhandle is considered like the wettest part of Florida. So they see a lot of rain and a lot of precipitation. So they probably will have more rain and precipitation as we move forward. And, maybe other places within Florida are going to see, less rain. I can think of maybe some of our agricultural areas where we might be either not having enough rain for the agriculture, or we could have things like saltwater intrusion that would be getting into that underground water that we're using for like irrigation or for drinking water. And now we can't use that water, because of that saltwater intrusion. So we'll have to find other sources of water for those areas.
Okay. And then there was a question about CO2 versus methane gases on climate change. If you have any additional comments on that. This person was under the impression that other nutrient gases have a greater impact on climate change. And there's sort of a second, so talking about that, and then sort of a second question, does mulch, ground covers, et cetera, that kind of stuff in the landscape affect climate change?
Yeah, that person is correct. Methane, for one, is I guess you could say, stronger greenhouse gas than CO2. And I believe also stays in the atmosphere longer than CO2 does, even though CO2 does stay in the atmosphere for a really long time. So it does have a greater effect. But CO2 is like the biggest input, I guess, of those greenhouse gases. So we still have to be concerned about methane because it is a stronger, I guess you could say, greenhouse gas. And stays in the atmosphere longer, so it does have a greater effect. We just don't see, I guess, as large of an increase of it as we do CO2, but it is something that we do have to keep track of as well. As far as mulch and landscaping, I probably should have prefaced my presentation to say I'm not a plant person. And so, and I do not know the science or information about if mulch affects, say, increases of greenhouse gases into the atmosphere or decreases it. I'm not sure.
Yeah, I know that they can, it holds a lot, it retains water, but, ground covers can keep the earth cooler, and, there are some benefits, but that overall climate change, I'm unfamiliar with that as well.
Yeah, I think anything you can do to reduce your water use is always going to be good. So.
All right, so moving to the next one. Why is there, and this is kind of going back, there's sort of like these dichotomies. So why is there forecasted a decrease in storms? So this is going to the storms between now and 2050, but an increase in all the other categories. I think that came from one of your slides.
Yeah, that's a good question. I think it's because we're not necessarily going to see like the number of storms increase. We're just going to see the intensity of the storms be greater. So I know like the past several years, we've kind of like gone through the whole entire alphabet of, the hurricane list, right? And so it seems like we're getting a lot of storms, but we, especially this year, haven't really seen a lot of them hitting land. But we have seen some that have been at greater intensity, like that have become stronger in a fairly short period of time. So, so I guess that just relates to thinking about intensity of storms, how strong they are versus the number of storms. So we just see a lot more like rainfall associated with storms, or the storms having, if it's a hurricane, greater wind speed. So that those are the things that we see that are increasing.
Okay, that reminds me of Hurricane Irma. It was like not even the worst storm, but it was so slow, and the amount of rain and how long it hovered, just sort of its symptoms were greater.
Yeah.
All right, so moving on, because we've got them coming in. So has there been any discussion on updating the hardiness zone map? And then another person came in and said that they are in fact updated every 10 years. But can you elaborate a little bit about the Florida hardiness zone map?
I can, even though I have also heard that they are going to be updating it. I'm not sure when the last one went out or when it was last updated. But yeah, I can definitely see that being updated as we move forward, especially as the climate normals, recently changed. Because of those averages have gotten greater. So I can see, yeah, definitely that changing.
If that conversation has started, or if that's just sort of something on the radar.
I'm not sure.
Okay. So stay tuned, folks, on that one. And then there was a question about seagrasses, coral reefs, fish, shellfish spawning, all of that stuff, and how all of this is going to affect those critters, our water friends.
Yeah, I didn't even delve into that. That's like a whole other aspect. So yes, we already see an effect across the world on coral reefs. So as the water gets warmer, the corals become more stressed, and they actually release like the algae that lives within the coral that gives them a lot of their food. So that's what coral bleaching is. So it's basically the coral releasing that algae. So you see more bleaching events because the water is warmer. It's greater stress for the corals. You also see more disease. So there's actually a disease that's come up and that's first started in our Florida corals, and that has spread through the Caribbean. It's I think it's called stony coral tissue loss disease, I believe. But so we see different diseases that are coming. Seagrasses, depending on where you live, seagrasses might benefit because they'll be less likely for the water to be cooler, so maybe less die off like in the wintertime. There might be more sun or more solar radiation, I guess I should say. So greater solar radiation that might help the seagrasses to grow. But as sea levels rise, because seagrasses do need sunlight in order to photosynthesize and to grow, they'll have to kind of move further inland. And if there's a barrier to that happening, then there might be less seagrass in that particular area.
All right, I'm going to kind of see what's happened in the chat since I stopped writing all this down. Are there any evaluations of the sun's solar storms and how they affect the Earth? Climate change is not new. It is recorded in the Earth's soil. So,
yeah, definitely the different solar, I guess, intensity or radiation from the sun is a factor. It's a natural process, so something that has occurred obviously in the Earth's lifetime. And I have to look back at what the latest research is. I guess what the biggest thing to take away from like the solar radiation is that that is something that's naturally happening and naturally occurring. It does have an effect, on weather and climate over time. But we have just seen a greater increase, of temperature in such a short period of time. That increase is not something in that short period of time that we've ever seen in the hundreds of thousands of years that we've been able to look at past levels of, say, greenhouse gases in the atmosphere. So it's not that we haven't seen increase in greenhouse gases in our atmosphere in the past. It's the rate of increase we've never seen.
All right, I'll probably ask this last one, and then if anyone else wants to kind of go ahead and unmute, that's fine. Someone asked about carbon sequestration, and of course it's a good way to trap carbon in our soil. So could we talk about that a little bit, expand on that a little bit?
Yeah, definitely. Yeah, that carbon sink, so sequestering carbon, and obviously plants and fungi and our forests, even like our mangrove system. So there's been some work showing that our mangroves sequester a lot of carbon, maybe more carbon than other plants. So our soils, even the sediment that's underground, so all those things, yeah, sequester carbon, and they are definitely a good, making sure that they are not, I guess, torn down or removed, is a good way to help to continue those sinks. And there has been some research, looking at other ways to sequester carbon, from the atmosphere. So not necessarily a natural way like with plants, but other ways potentially we want to be able to sequester carbon as well.
Awesome. And someone just made a comment, but it was a good comment, so I'll share it. So fungi does a great job in this carbon sequestration. So thinking about kind of reducing our use of fungicides. Yeah. So reducing all chemical use, yep, is a good thing. So yes, and let's see if we've got anything else. Is there anyone that just wants to unmute and maybe ask a question? Go ahead and do so.
I have about there was a slide that talked about ocean chemistry changing. Can you explain the changes in the ocean chemistry?
Yeah, that mainly relates to like ocean acidification. So we have our ocean to thank for a lot of the sequestering of CO2 that has happened over the years. Without our ocean, we would have way more CO2 in our atmosphere than we do now. So ocean absorbs a lot of CO2, and because of that, it has made the ocean more acidic. And so that ocean acidification has increased in a lot of areas, and that affects things like anything that would need carbon or carbonate to grow like our shellfish. So like clams and oysters and other things like that. So it's been affecting those and other, animals as well. But yeah, chemistry is related mainly to that increase in acidification in the ocean.
And that's because of the weather getting hotter?
It's because the ocean has absorbed a lot of CO2, a lot of carbon dioxide.
Thank you.
Mm-hmm.
Alicia, you're muted.
Okay, thank you. I do think we need to wrap it up here. I wanted to remind Holly of that link to a documentary that you mentioned at the very beginning. And as you guys go out, remember you need to thank you for sitting through this talk. Thank you, Holly. Remember you need to go back to your agenda and click on your next session from your agenda. And thanks for being with us. And when you finish up your day today, I hope you had a great conference. Make sure you fill out that evaluation when you get it. Help us in future conferences. And thank you so much.